Hey kids, in this video we're going to talk about zeros of polynomials and how to find zeros of polynomials and also how to create polynomials. There are three examples that we're going to go through, but take your time and listen carefully, and let's get started. Okay, in this equation, in this problem, it says determine the zeros of that equation graphically and algebraically. Now, let's first take a look at it algebraically. Now, to determine zeros, we set the equation equal to 0. So we're going to say that it's going to be 0. Nope. Get my pen going here. So we're going to have x cubed minus x squared minus 12x is equal to 0. And that's going to factor. We're going to pull out the greatest common factor of x, and it's going to be x times x squared minus x minus 12 is equal to 0. And then it's going to factor a little bit more into x times x minus 4 times x plus 3. And that's going to be equal to 0. Now, you've got a cubic, so we're going to look for 3 roots. Those roots are defined by the factors, right? So we know that there's a factor, there's a factor, and there's a factor. So our roots are x is going to be equal to 0, x minus 4 is equal to 0, and x plus 3 is equal to 0. Now x equal to 0, that's done. We don't need to fix that anymore. This implies that x is equal to 4 when we solve it, and this implies x is equal to negative 3. So there is algebraic solutions of that equation. Now if you were to plug it into your calculator, we know that there is going to be 3 roots. So we're looking for 3, or doubles. What we can do is we will go to our y equals. I'm going to turn off this guy right here, and I'm going to turn on this one, and we'll just type it on in. X cubed minus x squared minus 12x. Nope, that's not x squared. That's x times 2 minus x squared minus 12x. And then if you go to the graph, that's what it's going to look like. Okay? And we discussed in end behavior that it would have that kind of a shape, right? So I'm going to put this guy over here. Let me see, how about, yeah, right about there. That sounds good. Yeah. Okay, I'm going to put that guy over there. Okay, so we know that it's going to cross at 0. At negative 3. And at 4. 1, 2, 3, 4. And we know it's going to have that cubic shape like we've been looking at from prior units. Okay? Okay, so that's how you solve graphically and algebraically. Now, let's go ahead and look at a different example. Now we've got a quartic equation. So it's not asking us to factor it. It's asking us to sketch the graph first and label the x-intercepts, and then write the equation in factored form. So let's go ahead and put it back in our calculators. I'm going to turn it on by clicking enter on the equal sign. I'm going to turn off this guy, and then I'm going to look at the graph. Now you'll notice that the graph, it's a 4th degree graph, and a is greater than 0. So I know that the graph is going to have 4 roots. Whether they could be double or imaginary, we don't know. But I also know it's going to have a shape that's going to look something like this. Right? It's going to start and finish in the same direction, and it could have, if it's a 4th degree, it could look like a W, or it could look almost like a parabola like you've seen before also, depending on the middle terms. So this one has a shape of a W, and as you can see, it goes through the x-axis at negative, looks like negative 7, negative 2, 1, and 5. So this thing is going to have this kind of a shape. Did I mess that up a little bit? Yeah, a little bit. Let me just erase it a little bit. I'm just trying to look at this. I should have gone. So let me say 2, and then it should have gone. Let me see down. Let me see all the way down here, and then up through 1. Nope, nope, wait. Bad drawing. I'm a horrible artist. So these two roots right here should have been 7. What did we say? -2, 1, and 5, right? Looking at that graph. So I'm going to come down like this, up, back down, and then like that. That's what the graph is going to look like. And the x-intercepts are -7, -2, 1, and 5. So that's the graph in the x-intercepts. Now we know that the x-intercepts and the factors have that relationship, so we can work backwards to get our factors. We know that if -7 is a root, x minus -7 or x plus 7 is a factor. We know that if -2 is a root, x minus -2 is a factor. And we know that if x plus 1, if 1 is a factor, x minus, if 1 is a root, x minus 1 is a factor. And likewise, we know that if 5 is a root, x minus 5 is a factor. So the factored form is x plus 7 times x plus 2 times x minus 1 times x minus 5. Sorry about the handwriting. I'm kind of writing on the screen and it's jiggling all over here. Okay? So you can work backwards from graphs to factors if you can't factor also. All right. Let's go and do one more type of problem. Okay, now we're going to go ahead and find equations if we're given the roots. Now, I'm going to go ahead and shrink that up. So this says determine the equation of a quadratic whose roots are -3 and 4 and that passes through the point 2, -50. So you might think, okay, it's a quadratic equation, so I can just put in these factors. If -3 is a root, x plus 3 is a factor, and if 4 is a root, x minus 4 is a factor. And you could say, okay, well, there's my quadratic equation. It should just be x squared minus x minus 12. So let's take a look and see what that does. Now, if I plug in that, you'll notice that, let me go over here, and I'll show you the equation. This is that equation, and it works. But what is the problem is it doesn't go through -250, and that's because we've got an a value to consider here. Remember, I can multiply this whole equation by any number, and it's not going to change the zeros of the function. It's not going to change those. Here's what I mean. What I have graphed here is I have a times x plus 3 and x minus 4. You see that up there? And my a value is 1. So you'll notice that it doesn't go through -2, -50. So what I can do is I can show you that, see how the zeros don't change? If I take that a value that's in front, the zeros don't change. And it'll even flip it upside down, but it's going to cross the x-axis at the same place. So we have to figure out what that a value is in order to make this thing go through -2, -50, right? So here's how you do it. What you do is you use that in your equation that you've built. You start with that, but you remember that there's an a here. So what you can do is you can plug in your value of x of 2 and your y of -50. So we're going to have -50 is equal to a, which I'm looking for, times x plus 3. Well, x is 2. So it's going to be 2 plus 3 times 2 minus 4. So you're going to have -50 is equal to a times 5 times -2. So -50 is equal to -10a, And so you know that a has got to be equal to 5 when we divide both sides by -10. So now we can write our final equation, which is y is equal to 5 times x plus 3 times x minus 4. I'm holding this thing tight. So we want to multiply it out to get the final equation. So 5 times x squared minus x minus 12, and 5x squared minus 5x minus 60. That's going to be your final answer for your equation. So make sure you remember about that a there, that a value. It changes things a lot. All right, I think that's going to be about it, kids. We will see you in class.